morning, I am Dr. Kavitha Rani, Assistant Professor of Chemistry. Today, I am going to discuss about a topic, elimination reaction. Elimination reaction for the first UG students in organic chemistry part. The objective of elimination reaction for this video is the first introduction of elimination reaction and classification of elimination reaction, and classified elimination reactions are E1 elimination, E2 elimination, and the mechanism of elimination reaction and what are the rules for the elimination reaction. Elimination reaction is a type of organic reaction in which two atoms or groups are removed from a molecule without replacing any atoms or groups, resulting in the formation of a multiple bond. That is, a single bond is converted into multiple bond. That is, sigma bond is converted into pi bond. Elimination reaction is a type of reaction in which two substances are removed from a molecule. There is two types of mechanism. One type mechanism is known as E2 elimination reaction and two-step mechanism is known as E1 elimination reaction. Elimination reaction are classified into alpha elimination reaction, beta elimination reaction and gamma elimination reaction. The alpha elimination reaction in which the carbon atom from which the leaving group is removed is generally designed as alpha elimination, and the adjacent carbon is designed as E2 beta elimination reaction. This represents 1,2 elimination reaction. And mainly beta elimination is classified into E1 elimination and E2 elimination. And the mechanism for the elimination reaction consists of fundamental steps, that is proton removal, second carbon-carbon pi bond is formed and there is a breakage in the bond of the leaving group. Depend upon the kinetics of elimination reaction which occur mostly by two mechanisms, namely E1 elimination and E2 elimination. E is the represented as elimination reaction and number 1 or either 1 or 2 is represented as molecularity. For the E1 elimination reaction, the mechanism, E1 elimination reaction is a model to explain the particular type of elimination reaction. E stands for unimolecular elimination reaction, the steps following the elimination reaction in which two steps are followed, and first ionization and second deprotonation. Ionization, the carbon hydrogen bond break to form a carbocation intermediate, and deprotonation is the second step. The deprotonation of a carbocation gives a alkene. E1 elimination reaction represents the alkyl halides, that is tertiary alkyl halides, but possible for some secondary alkyl halides also possible for E1 elimination reaction. In elimination reaction, E stands for E1 elimination, E stands for elimination, and that is its molecularity, that is the unimolecular elimination reaction in which two steps are first ionization and second deprotonation. Ionization to form an intermediate, that is the carbocation. The carbocation stability also included for the ionization, and second step deprotonation and to form a alkene compound. And this is the stepwise elimination reactions E2 and E1. Tertiary butyl bromide undergo elimination reaction with the presence of an ethanol. A weak base gives a butene. The mechanism of the reaction is given, and first formation of a carbocation and then deprotonation gives the alkene. Then second one, E2 elimination or elimination by molecular elimination reaction. E2 is a elimination reaction by molecular. It involves one-step mechanism in which carbon halogen bond break to form a double bond. This specifies it is the E2 elimination reaction. E2 is a single step elimination reaction. The transition state is formed and it is typically undergone by preliminary substituted alkyl halide and possible with some secondary alkyl or other compounds. The reaction rate is second order because it is influenced by base and alkyl halide. So, it is called a bimolecular elimination reaction. The rate of the reaction depends upon the base as well as the substrate, that is alkyl halide. This is the general mechanism of the E2 elimination reaction. This is the N-propyl bromide undergoes elimination reaction in presence of ethanol, a strong base than ethanol, and it gives a propene. E2 elimination reaction to gives a propene using a base, that is a strong base. In even elimination we are using a weak base like ethanol, whereas in E2 elimination reaction we are using a strong base. For example, N-propyl bromide to gives propene. Two rules for this elimination reaction, that is Seyss rule and Hofmann rule. The Seyss rule for the E2 elimination reaction, the substrate which have alternate hydrogen bond available, it possible more than one alkene compound. The substrate which have eliminated beta hydrogen and more than one beta hydrogen is available, then to form a two products formation is two types. Here Seyss rule state that hydrogen will be eliminated preferably from the beta carbon which is attached to the least number of hydrogen atoms. Therefore, according to the Seyss rule, alkene will be predominantly which has a most alkyl substituted on the double bond, whereas the Hofmann type elimination reaction, it will be undergoes the hydrogen atom will be undergo the more substituted hydrogen atoms. According to that, this Hofmann rule says that alkene will be predominant which has a less alkyl substituted on the double bond carbon atoms. Thank you for watching the video.